a nice day. I am Meryem Yılmaz, and today I am presenting our project, Sentence Level Emotion Analysis of Scenarios. Our team analyzed the emotions in movie scenarios like Scream, Memento, Halloween, and the Shawshank Redemption. To understand their emotional tone and themes, we used natural language processing tools in Python and MATLAB to achieve this. My part will focus on why we choose this project, how it builds on test work, and its benefits, while my teammates will dive into the technical details. Let's get started. Our project aimed to break down movie scenarios into sentences and identify the emotions each sentence carries, like fear, joy, or sadness. We then grouped these emotions into broader themes such as fear or drama to understand each scenario's emotional vibe and genre. We tested multiple scenarios to see how their emotions matched their genres, visualized the results, and improved our analysis by balancing uneven data. This approach helps us explore how emotions shape a scenario's storytelling impact. Why did we choose this? Scenarios are the core of movies, and their emotional tone drives the audience experience. For example, a horror scenario needs fear to work, while a drama needs sadness. We saw an opportunity to use NLP to go deeper, capturing specific emotions and linking them to themes. Unlike most tools that focus on broad sentiments like positive or negative, this could help filmmakers or writers ensure their scenarios delivers the right emotional impact. Combining Python's fast tools with MATLAB's flexibility was a fun challenge to create something unique. We studied past research to guide our project. Sun et al. 2019 classified scenario genres by analyzing emotions in each line or sign, achieving over 85% accuracy. They showed that emotions profiles can automate scenario selection in the film industry, which inspired our focus on emotions. Another study, Go Emotions by Dembski et al. 2020, created a dataset of 58,000 Reddit comments with 98 emotion levels. There, Robert A model, which we used, scored 86-88% in accuracy, making it ideal for detecting emotions in our scenarios. Tangut et al. 2015 used LSTML networks to classify emotions in IMDb movie reviews, achieving 97% accuracy. Their LSTML approach, which outperformed other models by 30 40% for longer text, inspired our MATLAB work. We and Zhu 2019 tackled uneven data in text classification with essay data augmentation techniques, boosting accuracy by 5% for less common emotions. We used similar simple tricks, like reversing word order, to balance our data. These studies provide a strong foundation, but we aim to go further by mapping emotions to themes and combining methods. What makes our project special? Most studies use one method, like transformers or LSTML, and focus on basic emotions or sentiments. We combined both approaches for a richer analysis and mapped emotions to broader themes, like grouping fear and nervousness into fear, intense suspense. This is rare and helps reveal a scenario's bigger emotional story. Or simple data tweaks, like converting text to lowercase, were effective for our small project, adding a practical twist. This approach could help writers or studios refine scenarios to match their genre's vibe. My teammates will cover the technical details, but here's a quick overview. In Python, we use the Roberta model to read scenarios, clean out formatting like int or fade in, split them into sentences, and detect emotions. We mapped this to themes and calculated their distribution. In MATLAB, we balanced Unnavian data, turned text into numerical vectors, and trained an LSTM network to classify emotions. We visualized the result with graphs like histograms and word cloud to make them clear. This combo let us analyze scenarios like Memento and Halloween efficiently. The benefits are exciting. Our project shows filmmakers how emotions flow in their scenarios, helping them ensure the story fits its genre. For example, a horror scenario should be heavy and fear, and we can verify that. Writers could use this to tweak their scenarios before production. Our approach is flexible, combining Python's speed with MATLAB's custom models for works for different scenarios and genres. Plus, our simple data fix make it practical for similar project, inspiring other researchers or students to try similar ideas without needing huge resources. To wrap up,
Thank you for the introduction, Mariam. I am Osman Çağatay Çağlar. In this section, I will present the Python development of our emotion analysis system. I will focus on the technical challenge we faced processing script data and solutions I implemented to overcome them. Challenge 1, the reality of noisy script data. Our initial goal was to directly apply an emotion model to film scripts. However, we quickly realized that scripts are far from clean text. They contain significant noise formatting, character names, scene heading, and uh, like this, all of which confuse NLP models. As you can see from this visual, our early attempts yielded unclear and unreliable emotion predictions. Solution: Python powered text cleaning and structuring. Uh, to tackle this noise, I developed a Python-based text cleaning pipeline. First, clean script line. Uh, this function uses regex to remove script-specific elements like character names and scene headings and parentheticals. Then load and split tokenizes the text into sentences using NLTK and filters out irrelevant short lines. The cleaner output is significantly cleaner, structured data ready for our model. This pre-processing was a critical step for meaningful analysis, essential for any ANN application. Advanced models and the natural bias. With cleaner data, we upgraded to more advanced model, SAMLAW, Roberta-based co-emotions. This Roberta-based transformer model, shown here from Hugging Face, offers 28 emotion labels, allowing for much more granular analysis. However, a new challenge emerged. The model had a strong bias, bias towards predicting the natural label, even for emotionally charged sentences. This masked nuanced emotions and clearly highlighted the need for further model tuning. A key learning outcome from our course. Solution: intelligent, neutral, handling via Python thresholding. Mm, To address the neutral bias, I implemented an intelligent thresholding logic in Python, as illustrated by this flowchart. Essentially, if the model's top prediction is neutral, but its confidence score is below our neutral score threshold, and if the second best prediction is a non-neutral emotion with a score above mean alternative score, we override neutral with this more specific emotion. This simple yet effective Python if-else structure significantly reduced neutral predictions. For instance, enhancing usability and control the config.json approach. To make our system flexible and user-friendly, I integrate the config.json file to manage all external parameters. You can see this part. As you can see in this snippet, this file allows us to easily change the input script, model name, the neutral thresholds, and even the entire emotion to them map without touching the core Python code. We use Python's built-in JSON library to load these configurations. This approach greatly improved system flexibility, making experimentation and code organization much more efficient. K development earnings and in our class connection. This Python development journey provided several K learnings relevant to our course. First, the critical importance of data pre-processing for any real-world NLP or ANN task. Second one is gaining hands-on transformers experience, working with large language models like Roberta and etc. Directly connects to our study of ANN architectures and deep learning applications. Third one is uh, the necessity of iterative problem solving, uh, particularly in refining model outputs like addressing the neutral issue, aligns with the course objective of evaluating and tuning neural network performance. And finally, the effective use of Python libraries like regex, NLTK, transformers, PyTorch, or JSON and something. This was fundamental to building this system. Overall, this project was a practical application of ANN fundamentals, classification, and model tuning strategies discussed in our class. Thank you for listening to me. Now, Suame will talk about the operation of MATLAB code.
We are delighted to be here today to talk to you about our MATLAB project, about the sentimental analysis, text classification, in-depth learning, and in this project we use the data set for NLP, for emotions, thanks to the Hugging Face team. And in this project, the data set gives us chance to see views and sentiments. And I will explain the code that we made in order to uh, classify the sentiments from the scenarios transcripts. And first of all, you see there is a run file, and the steps that the code will perform are shown there. And in this file, it can be clearly seen that the project is conducted in 8 steps. And first of all, we will start by running the load data file. And in this file, we loaded the data train txt, that the dataset we took from Kaggle, and we read the file train.txt into MATLAB as a table with two columns, and one for reviews and one for sentiment labels. And since the file doesn't include column headers, we set read variable names to false and specified that text columns should be read as string. And in this line, you can see review and sentiment is adapted to two columns. And second step is augmenting the minority classes. And in this step, we realized that some of the labels had more samples than others. So we balanced the dataset by using data augmentation technique. For example, in this part, we added new texts by reusing them with lowercase. In this line, you can see, and we also used words by reused them by reversing the word order. And after the lowercase conversion and reversing the word order process is conducted with 50 and 30 percentages, we obtained an equal number of samples for each label. Like it can be seen in this part, all of sentiments now have same samples, same amount of samples. And in the third step, we split our dataset into training and validation sets, an 80 and 20 percentage as by using the cpartition function. Holdout process is conducted there, and we separated the input reviews and sentiment labels by assigning review column to training data and validation data, and the sentiment column to training output and validation output. In another step, the process text file is run, and in this part, we run this function to preprocess the text data, and we tokenize each sentence into words and convert all text to lowercase while removing punctuation. This prepares the text for sequence conversion. And let's look to the next step. It's about converting this sequence. Because this LSTM uses the numbers instead of strings, we converted in this file, we convert words into numerical vectors and assign an ID to each word in the training data. Then we can provide these encoded words, as in this line shown, to the LSTM. And finally, we convert the sentiment labels to categorical format for training. And next, we create a network. After the inputs are prepared, we use LSTM architecture, and we assign options, training options. And in this part, you can see the definitions of functions. The input is a one-dimensional sequence. Here, we put one-dimensional sequence to word ID sequence. This shows that. And in word embedding layer, we see every word converts words into 50-dimensional vectors. And in LSTM layer, with 80 neurons, this extracts meaning from the sequence. And we also established a fully connected layer, one output neuron per class, and softmax layer for classification, which is producing probability set estimates for each class. And in the classifying layer, this layer computes the loss according to the class table. And in options, we made the settings as 10 max epochs, as in the shown. And also, we used the ADAM optimizer. And after the max epochs adapted to 10, This training will be performed for 10 epochs, and batch size is 32, meaning 32 samples are used per training step. And data is shuffled, which means this shuffled at every epoch means randomizing the orders. And validation data is monitored during the process of training. The training process graph also is displayed. And next step, we see evolution the model. We evaluated the model that text after the text network is conducted. But first, we trained we used the training dataset and trained the model. Then we result as 82, almost 83% of validation accuracy, and the loss function is shown as in the figure. And this graph shows that the training process is successfully created. Then we use this model by testing them. After this training is completed, we evaluate our model. And in this test, we see this test.txt file is benefited from the website Kaggle. As I showed, the joy of sentiments included in this text, the test.txt more than others. But if we check a scenario transcript, for example, a film of Halloween, if we checked, we see sadness more than the other sentiments. So it shows the project works finally. And in the evaluation, we see a confusion matrix is also like that, and the results are shown. Thank you for listening.